Professor Dr. Seetharaman from Hindustan campus. Hi sir, how are you?
Fine sir.
Nice to meet you. Thank you for the time. Actually today now we are discussing about the people of particularly people in budding engineers. Okay. They are very much interested in the IT sector jobs or IT sector. Of course, they are in fact I can like to say that they forgot mechanical engineering or electrical engineering. Yeah. That was the case. We talk about this. Normally, the budding engineers are saying that and stating that only we have a job market in IT sector to be able to get a good salary and something. Yes. Beyond that, what I think is that I hope they have some lack of skills in mechanical engineering which is to be enhanced. So, in your practice, you might have learned about a lot of softwares which could be able to support the mechanical engineering.
Yes.
So, what is your opinion in that, and which software that you are very much, which software influenced you? Can you say a few words about that for the public?
Yeah, sure. What you are saying is right, because the current market, the people think that they have only the wide opportunity only in the IT sector. But my point of view, the students, the budding engineer, have a plenty of opportunity in the mechanical domain, especially those who have quite knowledge even in this Ansys. Because I had nearly 16 plus years of experience in this particular Ansys and various structural and thermal analysis. And quite some time I worked with this computation field dynamics. In the current scenario, we have only limited quantum of people on this particular domain. The students, those who are learned this particular structural analysis and thermal analysis, they have plenty of opportunities in automotive sector and the defense sector, even the sports. Because today most famous the game is for cricket.
Yeah.
So once the bowler has to bowl, what will be the velocity reached to the batsman and how they are doing hitting the ball. That kind of analysis also can be doing in this particular Ansys, so that even all the teams they require such kind of technology people for doing such kind of analysis. So it's my point of view as a mechanical, automobile, or even the mechanical science students have plenty of opportunities in this particular software once they have learned structural and the computation field analysis.
If that's the case, which would be the right time for the candidate to learn about this Ansys, and what is the enhancement that you would like to state to the student? This is the part that particular student can concentrate, so that their job market or skill set may help them in the near future.
Yeah, and normally the engineering students during the first year they get into some kind of basic funda engineering related kind of subjects. Once the students getting into the second year, probably we just given us some kind of basic analysis on this particular Ansys, and what will be the various kind of analysis can be doing in this kind of things that can be given to the students at initial stage. So the students while coming into the third year automatically ensure that will be created interest so that the students can learn further into this particular Ansys. And while coming into the final year, sure they can take up their project in the particular area. Sure, that will be given a good insight for them as well as getting placement in the top companies.
Which is a hot spot area that Ansys is a company, you can state some company.
Yeah.
Not to promote, but actually we want to take the content to the public. Okay. So which company, can you state some company which they are really using this Ansys which could help them in building any product or something? Like in any area, specific area like
my observation is Brakes India. So they are pioneer in the brake pad manufacturing. The current scenario, they are using Ansys. They are doing an analysis if the brake is pulled to the disc, how much heat has to be generated and how it has to be dissipated. So, and what will be the wear pattern of the particular pad. So even the Brakes India might be used this particular Ansys for their analysis. And Daimler India, that is formerly used for Mercedes-Benz. The Mercedes-Benz for normally passenger segmented car, but the Daimler India for division. So in that truck division, there also they are doing a lot of analysis using this Ansys, right? So even the crash test analysis also carried out this particular Ansys LS diagram. Even Volvo and each they are also the pioneers. They are doing a kind of using these softwares.
So I have to understand that if a student could be able to learn this particular answers only one software, okay, we can put a lot of things clubbed together in one particular software. Okay, I hope the job opportunity for us a lot, particularly in the core company.
Yes.
So this is to be seeded to the end mind of the future. Okay. Yeah, great. Anyway, very good thought process, and I think we are given something to be. So, what do you want to add more, and want to say to the students? Can you say, being a core mechanical engineer, so you are doing a lot of research using these answers. What is your suggestion that you want to say to them?
Yeah, that's good. Students, whatever may be the kind of getting into, whether it is become an entrepreneur or become an innovator or become and getting into any kind of company, you should be or you must thorough in the basics. What you are teaching in the various kind of subjects. Start with the set of material to till the unconventional listening process. You should understand the basic kind of things. Even during the interview process also, no one HR never asked you just derive the equations. They expecting that what kind of basics you have well known, how much you have understand kind of thing. So you must thorough with funda on all the core subjects in your program. Thank you.
Thank you, Professor. Nice meeting you. I'm very happy to be with Professor Dr. Prabhuraja from Brain Street Tech. His vast experience over 25 years in industry, R&D, as well as academia. Hi, sir. Hi. How are you? Fine. Very happy to meet you, sir. Normally, students start process. I was talking to the students. They are budding engineers. Yes. Normally looking for IT-based job markets, or their mindset has been totally thrown away to the IT sector. When I asked the question to them, they used to say, normally mechanical engineering or electrical engineering, any kind of core engineering is not having value. Do you feel that it's really true?
But the thing is, of course, really IT jobs, generally there's a craze. Not really have a good salary initially, and things are going like that. The only thing is, no, that's not the internet, because we see the development of any nation or country or in the world, and the product development and manufacturing is also an important sector. Even in the recently, our government, Karnataka government came to reach the right. I think we have reached even the 20%. The sector contributes to the GDP. The contribution is around 20%. This comes from manufacturing. We cannot entirely depend on IT-oriented services. Just because the work is related to coding and things like that. Manufacturing, though it used to be a little bit of in terms of salary, initially it is less generally. But once the students are quite proficient in this particular field, there are a lot of avenues to catch up and do the work. They can contribute to a larger extent to the industry. That is possible.
Then,
Quite a good thing in IT is that the other thing is we also talk about this problem. Initially, you feel that now you're getting into something that good salary is there. But once you reach that 40 plus, then the pyramid is what we call as a pyramid, it gets sort of vertical. And then it becomes very difficult to sustain for a longer period of time. Not everyone is able to sustain that. So that is why what I prefer is, even I'm not saying IT is totally ruled out. My thing is, if the students are having some knowledge in a particular domain, let us say mechanical, I am from mechanical. For example, I'm saying, from mechanical, if you have the knowledge, and it is not that you have to work in a core area, but even if you contribute in IT field. But the thing is, you are having your strong footage in mechanics. So that way, you have a job security as well. Because somebody cannot just replace this person or that. That's in general software, right? It's like everyone is, irrespective of the branch they study, everyone is sort of falling into it. Finally, it doesn't really, sometimes it becomes interesting. Whereas, like a ALM, for example, product life cycle management, what is that? A lot of developing metal working, a lot of mechanical products and building mechanical products. And the simulation, we talk about the vehicle crash and safety
That's what I want to even
biomedical. Let it be biomedical or any discipline. Now that simulation is playing a very, very important role for the simple reason that now industries they don't have the luxury of taking their own time to come up with the product. You have to cut short the product time. Right? But the best way is to basically run computer simulations as much as possible. Right? You try to validate your design to the best possible extent and immediately launch the product. That way, no customer wants to have a product now. Like, customers don't accept failures. Of course, it's not. The product is actually, it is going to be instead. Yes. So, before it is launched, it has to be fully validated. So, that validation part is not easy. What I'm saying is not easy to say. So, there are commercially available softwares. Very good softwares are available. Still, the students are expected to know they need to have a lot of strong fundamentals. And they cannot be merely tool users. Like a black box, like a software. It gives them more than that, what industry is expecting is they expect students to have some good fundamental knowledge. With that knowledge, you might use the software. You are expected to get some very reliable results. How to validate this? You can run some software to result. How far it is believable? Is authentic. After that authentic thing, it will come unless the students are good in fundamentals. They can never do that. So one thing that I think is that good in fundamentals, they can enter into computer-based applications like one approach I say. One thing is you will be an application engineer. You try to make use of the software in a very true sense. And one step ahead, even if you finish your PhD research, right? Then you come out and companies are paying very good salaries, like PhDs, for example, from IITs. They are very good in a very specific like Greek, for example. Nuclear power plant. Yes, about Greek, like continuous deformation over time. Only in that area they specialize. And they get some very good salary. Because, modeling a gas turbine made of aircraft. It's not an easy. Yeah. So, I just finish one small point here. This is one area where computer is playing a part everywhere, I'm saying. What is the application side? Okay, do it. Using computers, I'm saying. One approach. Second approach is you be the developer. Just like an IT, Oh, yes, of course. Yes, any software, they have revisions. A lot of newer things are getting versions. Versions are coming in place. Based on your background, you get into an IT-oriented thing, but with a mechanical background as your domain. Yes, it could be easy, it could be writing a lot of this. So, you have that particular coding, you're interested in coding, you try to connect with coding, and you go ahead. So, that will be sort of the better options instead of going into general software. Okay. And that's what I understood. So, from the discussion, I could able to understand that the thought process like the IT industry is good and valuable. Yeah. But the people, those who are in the core domain, they weren't able to understand that even people with the core knowledge, there is fundas with the application, which is also help them to get a lot of salary or job market is of course the same. This is the thing that students has to understand. Right? Yes, that's correct. The thing is now the world is basically the transformation that's going on. Everything is technology. Whenever we talk about innovation, once you want to do that, then your innovation is one thing. What you want to do. The second thing is how you are going to do it. For really accomplishing that, you must have a good fundamental knowledge and use of some software. Either you do coding or you use the existing software to the fullest extent. You come out with a real design. It could be a building, it could be a machine or sort of a precision machine or anything. It could be a ventilator. Pandemic. Yeah. So a lot of medical. Even top manufacturing companies turn into ventilators. So the technology, and even I would like to give a very simple example. In my opinion, if you take this water tech products, report this. A simple tap. You can see the revolution, right? You see, all along now, we have been accepting the water taps. It used to leak. Even we accepted some sort of normal product. Yes. But now you see this water tech product. Now it's almost, it has sort of monopolized the. Yeah. Everywhere anybody buys a tap for their residences or whatever. They're using this water tech. So what is the engineering behind it? And they mastered it. It is simple application. The idea is very simple. What is that in a tap? in your all your metal stainless steel products. Yes. And it's price wise it is highly competitive. Yes. What you used to buy for 1,000 rupees for metal, your stainless steel, you are going to get at 300 rupees. But it serves the purpose, and you see the that's what the real engineering has made. Yes. Yeah. I'm not talking about rocket science. Any simple product, how you apply your technology, your precision, your engineering part. You can do that perfectly. You can come out with the product. You can see the potential that the type of business. If you convert that into a business prospect, then somebody can there's a very clear proof. Exactly. That was very. If that is the case, sir, actually, which kind of simulation software that you come across, you feel that it's giving a really good, good reliable results which can be turned into a product directly. If that is the case, do you have any experience, any kind of other transit that question, like other one, like the transformation simulation itself has happened. Earlier, when I was studying and all, earlier there used to be some simulation experts they call yes, right? That means any English student when they complete the course, they will be sort of doing the design part. The analysis, what we call the simulation. Analysis, modeling and analysis. Analysis is basically, you want to try to understand how the product is going to perform. Performance based, structurally, if you apply some load, the beam is different. How much is different? That we want to predict. So that sort of predictive analysis, what is done is, if you look at the previous earlier scenarios, there used to be some dedicated analysis teams for them. Now, transformation has happened there, right? Because just now I told that any product anybody wants to figure out, it has to be the best possible solution. Yes. Like an optimum solution. Yes. With minimum weight. It's a maximum efficiency. So, now the designers, the engineers are expected to come out with the best solution, the first run. Not in the launch product. After 5 years, you don't have the luxury of releasing another version. It should be a better version. See, that is the transformation. So now engineers are expected to know simulation. It's like bread and butter. You cannot say I'm only designer. Yes. The simple simulations, fundamental simulations, every engineer perspective of mind is supposed to know. Without which you cannot design anything. Yes. So that's what we call the simulation driven design. So that is the transformation simulation. If the underlying word is simulation driven design. Which drives the design itself. Okay, it's not the earlier what we do is we design a product. When we run an analysis of the product, you see the performance. Now the engineers, when you want to design it and you simulate it, get the best possible design and you concept it. And in the present scenario, people, you do have some specialized analysis, like analysis we call them. And those people are masters at very specific areas. What I mean is just I told about the PhDs and like the fluid structure interaction. Those are high-end research areas, application areas. For that, we want some specialized simulation experts. Whereas for general design, day-to-day design, industries and any designer is expected to know simulation. Without which you are not, you cannot come. So that is the transformation that has penetrated so much into the ecosystem. Okay, that is the first question. Now, if you come into the type of software, like I have sort of extensively used Ansys right from the beginning. Most education institutions also now use very popularly known. And even Ansys, I understand that they used to sort of have some software pertaining to mechanical civil and all. Earlier. It was structural based. Earlier it was like. Now, after it, you can see that the Ansys has got a bundle of suits, right? Catering to not only mechanical but multi-physics. See, you talk about 80 domain. They got fantastic sort of applications brought under one umbrella. Yeah. So the thing is now, as you see the national education policy, it talks about interdisciplinary work. Okay, so exactly. It's not about it's not about simply what I know only mechanical. As a user, if I want to sort of build an electric vehicle, it is just not sufficient for mechanical to do only mechanical. But I should know interrelated, multidisciplinary. No, not at least reasonably about electric vehicle context. Without which I cannot really contribute to that electric vehicle. Exactly. So it's rightly one electrical engineering person who is working on electric vehicle. Whole thing is electrical. But at least 20-30% Essentially, converse to mechanical. Otherwise, how these two persons will jointly work and then they cannot bring the product. So, what the policy says is everyone understands and presents. You look at the product. You don't look about the type of engineering. What is the product wants? The product demands certain fields of engineering. And how to integrate these various fields to come out with the successful product. And who are all the engineers that need to work on the problem? It could be mechanical to electrical problem. Yes, like an electric vehicle. Electronics also. So that is how we are now the product. That way, that's one of the software is not the product couple of applications. So an engineer can easily sort of switch over from one module to another domain also. Yeah. Seamlessly, you have that interconnected side. So that way, it helps anybody who is working on a product or a complex or whatever. It's quite, it becomes quite easier for anybody to sort of promote the product successfully. By running different types of simulation, it could be mechanical or electric vehicles or product. Why is mechanical simulation? Because electrical simulation. That sort of interconnectedness, interplay, that type of things can be handled efficiently by Ansys. One, a very good software like Seetharaman, Ansys Green, for example, they got a very good product on CNC. CNC, like aerospace, they will look at fluid movement or aerospace, whatever, aerospace or like that, they are not very much. So, this was a basic understanding that people have to know about this kind of simulations. It should be given into the, it should be included into their new syllabus, and they have to have these kind of skill sets. This may turn them into really future to get a lot of good jobs in a long way. So that way, you should take our college and for the technology. What we have done is for mechanical engineering. We have this subject called element analysis. If anyone understands, one of the very popular approaches to perform simulation. Yes, right. So what we strongly feel is that if you offer only the laboratory to the students, only simulation as a tool, they just don't know how the simulation is done. What is the mathematical background to it? So that knowledge is not given. That is why we have a semester. We have the mathematical analysis course subject plus a lab attachment. That is the mathematical analysis level. So you know the theory important. We also try to do the big practical one thing. Second important thing, the thing is we brought out another very important sort of pedagogy that we talked about. Earlier, any laboratory experiment, we used to have some sort of exercises. Any lab, doesn't matter. Normally is not the same, of course. Normally, we have certain kind of syllabus and exercises. Generally, the mode of teaching is used to have some kind of exercises. Students are used to perform. And when they undertake some examination, out of these 10, one of the exercises will be given. By random choice, they will get 1 or 2, they will try to do it. Yes, that is the normal way of validating the student performance. Now, presently, what we have done is, we don't tell them all the time. Change, transformation. You're also learning, right? Yeah, it's evolving. Yes, it is evolving. So, what we have done is the curriculum. If you look at our lab curriculum, plan is the first 5 weeks, you try to sort of expose them to different types of domains. So, how to handle a structural analysis problem. So, one-dimensional, two-dimensional, three-dimensional. Similarly, some amount of heat transfer, because thermal is very of course, and some amount of fluid. 5 weeks, approximately, I'm saying, out of 16 weeks per semester. Okay, there's one store around the 16 weeks. So, 5 to 6 weeks, you try to give them an overview about, let us say, Ansys, for example. That software, intro is given. And how to handle such things in generic parallels. Okay, that intro we used to give them. Okay, with that, I will say, remaining weeks, the students have to sort of select a topic. They have to do a case study. You have to identify a product or problem. You have to perform an analysis. It's not just that you are running the problem only once. You need to do some iterations. Come up with the best possible solution. And you make a presentation, you get the marks. Exactly. That sort of analysis. This is automatically raise the creativity of the learning. We talk about experience, project-based learning. So, the thing is now the transformation education is going on is it's not merely, the earlier teachers, we like students, a lot of videos, and learn. But the point is, it's not merely learning from books or reviews. unless we put that learning in practice, unless you burn your hands, unless you do something, then how can you master a particular way? So that is the sort of idea. And we try to implement. This is that and the students need to do some projects and evaluate. And one more interesting thing I want to in that process, the most important thing I want is the faculty side, teacher point of view. If students undertake different problems, it becomes experience for us. They are also learning along.
Yeah, exactly.
That's what I'm saying. Yeah. It's not the monotonous, I learn only 10 exercises, I do the 10 exercises, I repeat them, students repeat them, I give them marks. So that's the learning the faculty. We are also stagnant. So that's the learning cycle. So you only explore the options, more sort of problems we handle. And students sometimes have excellent problems they do it. Yeah, students will feel, yes, what is a very good solution and becomes learning experience for us. That way, our experience grows. In real way, with the faculty able to give that rich experience in problems, industry problems, master's projects. We have the confidence. See, that is, it's like the cycle. Goes like the cycle. It's a closed loop. You do something, it goes up and it comes back. So slowly we are raising our bar. Not only we also need to raise the bar. Then only we can solve the real industry problem. Otherwise, we will be bookish. We only casting some bookish knowledge to students. Never they will actually go on our fingers. They will solve the basic problems. We are like a very.
Yeah, I was very, very excited with that. No, nothing. This has to take with the students and a lot of people. They doesn't know what's the reality. So this is to be done actually a paradigm shift because we're talking about transformation. Yes, and particularly the students from the core domain should have this kind of knowledge. I hope you have done.
One more important thing I want to add here, very important thing is many companies, all companies are not they look for this gendering as a CSR. So girl students have a lot of opportunities because they have some percentage. And we are seeing in our PhD like that. Okay. Mechanically, a few girls are taken for 4 to 5, but they enter with very good companies. Because they want some girl students. Yes, that's percentage. So they have a relatively better chance, I think, than the boys. Yes. I don't know for what reason, but generally the girls, they don't know that. Everyone goes into CNC and these.
That is also a good message.
Yeah, because mechanical they come for recruitment. As of that, generally they want. So generally they look at it. They want some good students, but if these girl students perform relatively better, they will get a job. They're seeing year after year. But somehow they don't know this hidden thing is there. Maybe they can explore.
Anyway, sir, thanks for your time. I hope that we have given a lot of inputs to the public and independent minds. Thank you, sir.
Thank you so much.